Welcome friends and students. In this video I'm going to talk about the moments and center of mass of a planar lamina. So a planar lamina is a flat piece of material, and the density, we call it rho, is constant. And as we know, when we say constant, that means that the mass is equally distributed. If the density is constant, that means that the mass is equally distributed. So per area. Okay. So you can have an irregular as well. You have an irregular piece of material. In that case, you need to use the concepts of calculus to find the moments and center of masses of such a planar lamina. So for example, let's say you have two functions. We call this one f of x and this one called g of x. And then the interval is going to be from a to b. So f of x and g of x continuous. On AB. So your lamina looks something like this. It's basically this piece inside here, your planar lamina, and it's a thin plate of lamina. So as you know, density is equal to density is equal to rho, the Greek letter rho, and is equal to the mass over area for this planar lamina. So to come up with formula to find the moments and center, we need to divide the interval we need to partition the interval into thin rectangles equally. So we'll call it delta x. So they're all delta x's. Of course, this one we're gonna call it delta I, and we're gonna choose one in the middle randomly. That means that the height of the rectangle is gonna be equal to the height is gonna be equal to f of x minus g of x over 2. No, I'm sorry, f of x minus g of x, yes. F of x minus g of x, yes. and then the width is equal to delta x. So the mass of the mass, and let's suppose the moment of this rectangle is gonna be at the middle here. That means that to find the distance from to find this distance, this vertical distance, or if it's in the middle, all you have to do is that distance is equal to f of x plus g of x over 2. Okay, so I'm gonna delete this. Remember this, put this in your head, okay? If not, write it down, this thing. So knowing these little things here, we can say that the mass of that rectangle is equal to rho times the area and that's equal to rho times the area is going to be equal to f of x minus g of x times delta x. That means that the moment is going to be equal to rho times the area times the distance of the center of the rectangle from the x, from each x. So that's equal to rho times f of x minus g of x delta x times f of x plus g of x all over 2. But remember, this is little xi for the ith rectangle. So a concept that we used before in calculus is that if we let the limit as n approaches infinity of this whole thing of moment, we're gonna get a better approximation of that the moment of the entire planar of this each moment. So it will be the moment of the lamina. Okay. So this is the way we derive this this formula. So now let's we have the mass, we have the moment. All we need is a formula for the total moment. So I'm gonna write it down. Okay, so for the center of mass. Okay. So remember, because we have a planar, that means that we have an x bar and a y bar. So when we took the limit as n approaches infinity, that means that we can transform it into an integral. So this whole thing can become, remember, we're gonna take it from the interval a to b. Then we can pull out the row, and then we have f of x minus g of x times f of x plus g of x over 2 dx. Remember, delta x, when you transform it into a limit, is going to become the dx. And for the y, becomes rho a to b. And then, remember, this distance for the y is going to become as follows. So it's going to be x times f of x minus g of x delta x. Okay. But because we're doing x bar and y bar, all we need to do is we're gonna divide by the total mass. So what is each mass? Each mass is gonna be as follows, like this one. So each one gets divided by the mass. And let's write the formula for the mass. 1 second. So remember, the mass of the planar, we did n approaches infinity, so that means that the mass is going to be equal to, okay, so we remember the mass of the planar was equal to density times the area. So this m is equal to integral of rho A to B of the area. And what is the area? The area, of course, we're gonna have delta x, and then we're gonna have this one. And then if you put this m over here, so this whole term, we can, to make it clear, we can put it as follows: rho over m, rho over m. Because we're talking about mass, so that means that that's a number, that's a quantity. So rho over m times the integrals that we just talked about. And we can do this because we let the limit as n approaches infinity. So thank you very much. So these are the formulas. For the mass is this one, and for the center of mass it's going to be this one, each one for each coordinate. So thank you very much. Don't forget to subscribe, please. Your support is well appreciated. Thank you.